Chapter 7. So transformation. What is transformation? So first of all, when we start learn transformation, we need to know there are 3 components, which is really important. So what are they? So the first one we say is original function. I don't like this color. Original function. What we use is y equals to some x in terms of x. That's how we write it. Okay, y equals to some x. So y equals to 2x plus 1, y equals to x to the power of 2, y equals to 3x squared minus 2x. We use y and x to represent original one. And then after some transformation. So I'll say after some transformation description, we describe it. Okay, we describe what's the transformation. Well, I'll tell you what kind of transformation we will have. So I'll say maybe a reflection in the x-axis and dilate, move it like after a series of transformation, we have our resultant function. Okay, we end up as our resultant function. So we use y dash and some x dash to represent this. That's the 3 stage. Okay, that's the 3 stage we have. We have some original thing, and after we apply something, we end up with some new thing. Okay, to distinguish the first one and second one, we will use the dash to distinguish between them. So for example, this one we have y equals to x squared. Okay, that's my original. And then say translate 1 unit up. Okay, that's the instruction. I tell you what's happening. So what's the graph looks like? It must be x squared plus 1, right? That's the new graph. So I will say that's y dash equals to x dash squared plus 1. So to distinguish between the new one and old one, we use the dash to say that's the result of the previous question, okay, previous function. So that's the 3 stage we will have for a transformation question. So the type of transformation question, okay, so what kind of question we'll have is stage number 1, stage number 2, and stage number 3. We can give you any 2 stage and ask you for the 3rd one. Okay, I can give you any 2 stage and ask for the 3rd one. For example, I can tell you, oh, there's an original question, which is original function y equals to x squared. And after, like I described it, after transformation of 1 unit to the right, okay, tell me what's the resultant function. I will ask you what's the resultant function. Or I can give you, this is the original function, y equals to x squared. You have a new function, that's y. The resultant one is y equals to x squared plus 1. Tell me what's happening. Okay, what's happened in between? Like, you need to answer, oh, there's a translation of 1 unit up. So you describe it. Or I can tell you, there is some function, I don't know what is it, but after a transformation of 1 unit up, you have a new function, y equals to x squared plus 1. Please tell me what's the original one you have. So that's the 3. You only have 3 type of question, which is those 3 type. Okay, give you any 2 stage and ask you for the 3rd one. So that's the only 3 type of questions you will have in the whole chapter. Okay, in the whole chapter, that's what we learn. That's what we learn. All right, transformation. There are only 3 types of transformation we'll talk about. The first one is translation, second one is dilation, and 3rd one is reflection. Well, we know what are they, right? Translation is move left, right, up, and down, and dilation is stretch it this way, or stretch it this way, or compress it this way, or compress it this way. So it's kind of a stretch or compress. So that's dilation. And reflection is even easier. It's reflect in the x-axis or reflect in the y-axis. The graph is go upside down or go left, right. Okay, vertical reflection. Only 3 times. So the order of describing translation, dilation, and reflection is very important. So in other words, if I say translate 1 unit up, then reflect in the x-axis, that will be different from reflect in the x-axis, then translate 1 unit up. They will be 2 different things. Okay, so the order is important. We all say the same type of transformation, but the order is different, then the resultant graph will be different. Let's just do the example. If we have x squared, y equals to x squared. If we move up by 1 unit, and then reflect in the x-axis, that's 0, 1. So reflect in the x-axis. Can you see that's my final graph? Like this green one is my final graph. Like move up and then reflect, that's my final graph. But if we think about this one, okay, that's my start graph, y equals to x squared. And if I reflect in the x-axis, that's this graph here, right? And then I move up by 1 unit. Move up by 1 unit, yes? Oh.
Yeah, so, but like I'm wondering, if you wanted to switch around to some thing, would you like switch a second, you know what I mean? Like you'll do the first, like in the x-axis and then translate 1 unit down.
Yeah, like that will result in the same thing. Yeah, that will, and that's the next thing I will talk about. But like this thing I talk about is if you just swap the order without changing any number or like direction, you're not going to end up with the same graph. You can see that we end up with 2 different graphs. So the order is important. The order of when you describe things will give you different graph. Okay, will give you different graph. So we'll talk about more about the order, like because it's like a really hard topic. So I'll talk about this more later. But this will give you a general idea on why is different. Okay, a simple example show you why is different. And same as Oli said, if we can change this one to move down by 1 unit, then we'll end up with the same thing. So different dilation will still end up with the same graph. That's possible as well. So if I reflect in the x-axis and then move down by 1 unit, then we will have the same graph as the first one. Okay, so it's not going to have only one way to describe things. There's always multiple ways we can describe things. And the order will influence things, and the unit, whether move to which direction, will influence the final result as well. So everything, well, we need to consider about that. Okay, everything we need to consider. So this is an example to show you the order is important. Also, when you describe things, okay, give you the resultant function, give you the original function, ask you to describe it. Your order is very important as well. You can't say in any order, okay? Your order is very important. I'll talk about the order later, like in the next 2 pages. But the normal order you describe it is DRT order. I think you may heard about it. So DRT order. We'll talk about dilation, reflection, and then translation. So it's not 100% you must do that. But that's the suggest order. Okay, that's the suggest order. You need to better do it within that order. But if I really want to do translation first, and then dilation, and then reflection, that's all right as well. You just need to make sure your number is correct. Okay, the number is correct. That's the next thing I'm talking about. And the third thing is the basic shape of the graph after transformation will not change. So what that means, That means a hyperbola graph are not going to become another type, which is a truncus graph after transformation. A hyperbola will stay as a hyperbola graph. Okay, exponential will stay as exponential. A square root will still stay as a square root, and quadratic will still stay as a quadratic graph after transformation. The type of graph are not going to change. Okay, so transformation is only do some stretch, some reflection, some movement, but the basic type of function not going to change. There's only one exception, which is the sine graph and cosine graph. Sine graph and cosine graph can achieve each other by transformation, but because we haven't learned sine cosine yet, we'll talk about that later when we reach that exercise. But if you have an idea on what sine graph and cosine graph looks like in year 10, if you have a basic understanding on that, you can see they have the same shape, exactly same shape. And by movement, you will achieve the same thing. So that's why sine and cosine is the exception, because they originally have exactly the same shape. So that's why we can achieve that by transformation. Okay, so the last thing I'm trying to convince you to use is a complex, well, it's not complex. It's a longer method, but it's a safe method, which is called mapping. I know like students like to do transformation by look at two equations and tell me what's going on in between. That's not a safe method, because when there's multiple stage and there's more transformation happening, you can't really see it at once. So mapping is the best method I find to deal with transformation, and can 100% make sure you definitely can get it right. Okay, I can make sure you can definitely get that right. So at the beginning when you learn it, you think it's boring and like you think why it's not necessary, why we use this. But when you go for complex questions, you can see the advantage of this method. So number 5 is I'm trying to convince you to see and at least try this method, especially when we do with page 5 and 6, when we do the complex question, you can see that. Okay, what's mapping? Mapping method is to connect the original points and the new points together. Okay, the original points and new points together. So let's do a simple example. The first thing we talk about is translation. Okay, the first thing we talk about is translation. Think about the easy thing. A point, okay, single point, 0, 0. After translate 1 unit to the right, what this point will become? 0, 0, translate 1 unit to the right. 1, 0. Yeah, 1, 0. Okay, according to like what we talked about before, 0, 0 is the original function. We said that's x and y. And 1, 0 is after transformation. We said that's x dash and y dash. Okay, old point and new point. Old coordinates and new coordinates. And you think about a graph. Okay, so x squared. All the points will move to 1 unit to the right, right? Every single point will be shift 1 unit to the right. So therefore, what kind of expression I can write is the new x is the same as old x plus 1. That's according to this transformation what we can write. Okay, an equation to connect the old points and new points together. And we make the new point to be the subjects, because new point will be the old point at 1. Okay, new point will be the old point at 1. But you just move to the right, the height doesn't change. So the new y is still the same as the original y. Okay, the new y is the same as the original y. That's the mapping method. Okay, that's the mapping method. Okay, so there are 2 ways we can describe transformation. Okay, the language about transformation is very important as well. So when I ask you to write the transformation, you need to give me particular language to write it. So the first type we can say is translate A units to the right, translate A units to the left, translate B units up, or translate B units down. That's the first group. Okay, that's the first group, how you can describe it. The second type is more textbook like to use and the paper like to use. When you see this, you need to know what that means. Is translate A units in the positive direction of x-axis or to the y-axis, or translate in the negative direction of x-axis and y-axis. So it's the same as moving left, right, up, and down. So there are two types like you can use to describe it, and the second type is more for textbook or exam papers. They like to write in this way. It's more like say official way. It's more like they want to use the longer sentence to describe it. So you need to know what that means. Okay, so let's directly jump to one question. That's the mapping. Okay, so relate x and new x and new x and old x, new y and old y together by equations. So let's have a look at this one. Find the rule for the image. Okay, let's think about what do we have. Stage number 1, stage number 2, and stage number 3. So what's this type means? This question asks you, find the rule of the image of the graph y equals to y, or y equals 1 over x. So the first step is I have the original graph. That's y equals to 1 over x. And then add the translation 2 units in the positive direction and 1 unit in the negative direction of y-axis. Okay, so this is the same as say that 2 to the right and 1 to 1 down. Yeah, 2 in the positive of x-axis and 1 in the negative of y-axis. So 2 to the right and 1 down. Find the rule for the image. So number 3 is what I'm interested in. Just give you 1 and 2 and ask for number 3. Okay, number 3 is what? Is the resultant function. Okay, is the resultant function. The resultant function is in terms of what? In terms of x dash and y dash. You want to find an equation in terms of x dash and y dash. Okay, you want to find an equation in terms of x dash and y dash. That's what you want to know. Okay, you want to get in the end. So let's have a look what we can do. So according to number 2, what I can give is the mapping. Okay, what's the mapping? 2 to the right. So the new point will be the old point plus 2. And 1 down, the new y will be the old y minus 1. That's what you can give. Okay, 2 to the right because the old add 2 will give you new. The old subtract 1 will give you the new y. So that's the equation we have. Can you see I have connect x and y, x and x dash, y and y dash together. So I want to find a way. To have an equation only contain x dash and y dash. Let's look back. In this equation, I have x and y. If I can replace y by y dash, I can replace x by x dash. I will end up with the answer I want. Okay, so if I want to replace y in terms of y dash and replace x in terms of x dash, what I will do is I make x to be the subject. X equals x dash minus 2. Y equals to y dash plus 1. They are equivalent. Okay, they are equivalent. According to that, they are equivalent. Now I can do replacement. I can replace things in that equation. Y will become y dash plus 1. X will become x dash minus 2. So I will rearrange it. What I will end up with is an equation contain y dash and x dash, and that's the new graph. You know that's the new thing because x dash y dash is the new, okay, new point, resultant. So that's my final answer. When you answer things, you can get rid of the dash. With the dash, without the dash will be the same. So you can get rid of the dash here. That's the new function. Can you see why we make xy to be the subject? like later, because I want to replace the x in the equation, replace the y in the equation. So that's why I have to get rid of the x and y in terms of x dash y dash. That's what I want to achieve in the end. That's the method of mapping. Okay, that's the method of mapping. The first lesson is the most hard lesson and is most important lesson. So we use the simple transformation to talk about all the types of question here. So that's the first type of question. Give you number 1 and number 2 and ask for number 3. Let's have a look at part B. I want to change the question for part B a little bit. So find the rule of the original graph. Find the rule for the original graph. And don't want that. Y equals to that is the resultant function. And the transformation is listed. Okay, transformation is listed. And the transformation of 3 units and blah blah blah. So I want to revert. I want to change the question a little bit. So I don't know what's the original, but I know what's the transformation. I know what I end up with. Okay, the resultant function is y equals to x plus 1 squared minus 2, and then the transformation we apply to y equals to fx is this. So I want you to find the original question. Okay, find the original graph. That's how the question has been changed. So if we think about that, what we get is this one. This one is called the resultant function. Resultant function must be right in terms of x dash and y dash. So I will add the dash by myself. Y dash equals to x dash plus 1 squared minus 2. That's how I'm going to write it. I will put the dash. It's not going to show the dash in the question, but I will show it. Okay, when I write it, I will show it. What I also know is under a translation 3 units in the negative of x-axis. So left 3 units and 2 units in the negative direction of y-axis, which is 2 down. What I want to know is number 1. What I want to know is number 1. So what I can write here, well, what I want to achieve is a function in terms of x and y. So that's what I want to achieve, because original, I want original, that's in terms of x and y. So left 3 units, what I can write is x dash equals to old x minus 3 and y dash equals to old y minus 2. That's what I can see from the description. Okay, last time is I want to replace y by y dash, replace x by x dash. But this time is I need to replace y dash and x dash by xy. I want xy, so I need to replace that by xy. But can you see, that's just good. I can just do replacement. Okay, I can just replace it. Y dash is y minus 2. So I don't need to rearrange the equation now. I can just sub. So y minus 2 will be the same as x minus 3 and then plus the 1 squared and minus 2. I have replaced x dash and y dash by x and y. Okay, by x and y. Why I don't need to rearrange it? I just have the thing I want. Okay, I have x dash. X dash is what? X dash is x minus 3. Y dash is what? Y dash is y minus 2. Just good. Replace it. So what I have is y equals to x minus 2 squared. And that's it. Plus the 2 on both sides, that's it. So that's the original question. Okay, original function. Question? Any question? So this diagram helps us to see exactly what we have and what we want. So the new graph must be dash, okay, x dash and y dash. And then you see what do you have and how I can replace the thing I have. That's what needs to be the subject. Okay, I have x dash y dash, therefore x dash y dash needs to be the subject. I have xy in that question, therefore xy needs to be the subject. So what do you have? You make that to be the subject and then replace it, and then replace it. That's what we should do to this two type of question. Okay, that's when you have 1, 2, you ask for 3, and you have 2 and 3, ask for 1. So that's the two type of question we have. And if you can go to the next page, you can skip the step. Okay, the step is the same as what we talk about. That's just for help you to memorize it. Let's have a look at example 2. Describe the transformation that transfer this to that. Alright, still do the same thing. Step number 1, step number 2, and step number 3. That's how help us visually see it. So what we have is original one is this. And the new one is this. I will add the dash on it. Well, to distinguish the thing, I will put the dash onto this. Okay, what I want to know is in the middle. Okay, in the middle. Remember, according to, for example, if the middle I have translate 1 unit to the right, what I can get is x dash equals to x plus 1, right? And move down 2 units, what I can get is y dash equals y minus 2. So if I can find some connection between x dash equals to some x and y dash equals to some y, I should be able to talk about the transformation. So that's what I want to get. Okay, if I can write some connection between x dash and x, y dash and y, I should be able to talk about the transformation. So this is the most complex type. Okay, it's the hard type to understand. Okay, those two questions, those two functions. What is the how I can say that? What's the type? What type of function is that? What's the name of the function? Square root. Okay, if it's a square root function, I just want to leave square root on right hand side. Everything else I want to move it to left hand side. What do I mean by anything else? Like any dilation in the front or any minus or plus value at the back, I want to move it to the left. So what I will do in this case is I will only leave the square root, this, on one side. Other things all to the left. So this is the basic rule. Or say we can treat this as like the house. Okay, we have a house which is shaped as a square root, and then x minus 1 and x dash plus 2 is the people who live in this house. Okay, what I put in this house. And the minus 1 plus 2, they like the flowers around the house. They should be removed from the house. I want to see what actually the house looks like. I want to see the basic rule, what the rule looks like. So everything else like flowers, the stones, everything needs to move to the left. So what I will do is y minus 2 is the same as square root x minus 1. And this side is y dash plus 1 is square root x dash plus 2. That's how I want to make the two sides look the same. Okay, they are balanced now. Like they are balanced now. So they are identical. We can say they are identical. Identical form. Okay, identical format. Then what I want to do is I want to see what happens to x, what happens to y. I want to connect x and x dash, y and y dash. Therefore, I will make y minus 2 to be the same as that. And the house, the people who live in the house should be the same. That's how I should equalize them. Okay, that's how I should equalize them. Left hand side equals to left hand side, right hand side equals to right hand side. The side of left is dealing with y. The side of right is dealing with x. After that, I will make y dash to be the subject and x dash to be the subject. Why I make them to be the subject? The reason is here. I want to describe it. How I can describe? Must be the new thing equals to old thing and what? New y equals to old y and what? Okay, so I will make x dash y dash to be the subject. If you make xy to be the subject, then you get something wrong. Okay, you get something wrong. You need to have x dash in terms of x, y dash in terms of y to talk about the transformation. So my answer will be stop. So the answer will be translate 3 units to the left and translate 3 units down, because new y equals to old y minus 3, new x equals to old x minus 3. So is translate 3 units to the left, translate 3 units down. That's my answer. Okay, that's my answer. That's how we describe it. That's how we describe it. So for Casey, this type is totally different from the other two types. We have the first step needs to rearrange both equations to make them to share the same format. And then we equalize both sides to make us to compare x and x dash, y and y dash in order to write the transformation. So that's quite different from the previous two types. Okay, it's quite different from the previous two types. Let's do a last one, which is this one. Can you see this one is interesting? Why is interesting? The rule is not given. It just gives you a vague idea like fx is the rule. But what is it? Whether it's a square root, whether it's a quadratic, whether it's a cubic, doesn't tell us. But actually you don't need to worry about it. You just need to say, oh, there's some kind of house. I don't know, it's a not visible house. So fx, I know there's something. And the people who live in the house is x and x dash minus 3. So that's the family live in it. So that's all you need to know. So it's actually easy to deal with y equals to fx case. So again, what we have. Number 2 is not given. Number 1 is y equals to fx. Number 3 is y dash equals to fx dash minus 3 and then plus 2. The rule is f bracket. The rule is f bracket. F and something live in it. So what I need to do is y dash minus 2 equals to fx dash minus 3. That's the thing we need to do first. And this one will stay the same. It's perfect because only fx on one side. Now I will equalize both sides. Y equals to y dash minus 2 and x equals to x dash minus 3. You won't equalize fx and fx minus 3. You will equalize only the family in the house. So you equalize the people. So x equals x dash minus 3. And then because you're trying to describe what's happening, you need to make y dash to be the subject. So it's the old y plus 2. And the new x is the old x plus 3. Okay, that's what we have. So therefore, it is translate 3 units to the right and translate 2 units up. Okay, that's the answer to step 2. That's when you know 1, when you know 3, how we should get step number 2. Yeah, how we get step number 2. We need to make x dash and y dash to be the subject. Alright, I'm not going to continue with the next one. We'll learn that tomorrow. But you should understand fully what I talk about today. Okay, what I've talked about today. So today is the really important lesson. Everything else will be based on what I have learned, I have taught today. Okay, so today is really important.